Assalamualaikum and good morning, students. Okay, so today we will move into part 2 sample forming. Okay, so you will refer to the WhatsApp that I sent in the group. Okay, for the example 5.5. Okay, before that, I will show you what is actually the part 2 sample forming. Okay, so this is the slideshow that I've sent in the group. Okay, so two sample test for means with paired sample. Okay, so the hypothesis testing for the difference between two population means when two sample observation are dependent. Okay, before this, what we'll do, okay, from the t-test, okay, that we do before, it's actually the sample from the independent. Okay, so for this one, okay, for the paired sample, okay, what is the comparison is paired sample will be using the dependent. Okay, in many situations, data from two samples are naturally paired or matched. Okay, meaning that when you are doing the data about before and after, okay, so it will become the dependent variable. All right, between the two groups. When paired sample are used, a paired t-test is more accurate than assuming that the data come from independent population. Okay, D mean paired difference for the sample, mu D. Okay, mean of the paired difference for population. Okay, so the hypothesis, actually we will compare to the zero. Okay, to the zero value. Okay, so the mu D is the mean difference between the paired sample. So the Excel data analysis tool, we will use the t-test paired to sample for mean, okay, from your data analysis in the Excel. Okay, so we go to the data. Okay, so order fulfillment picking process change. So this is the data. Okay, so I will read the example. Okay, order picking is a process in the warehouse supply chain process, and it is a labor intensive, expensive process for every warehouse. The manager of a warehouse tends to improve the picking rate to increase the efficiency of the warehouse performance with no change in the labor. The Excel file order fulfillment picking process change contains the picking rate by warehouse order fulfillment workers before and after the improvement of the order picking process. Does the new picking process improve the picking rate of the pickers? Okay, so this manager would like to know, okay, whether the new picking process can improve, okay, can improve the picking rate of the pickers. Okay, so you will have about 13, okay, 13 data, okay, before and after. So that's why it will become the paired sample t-test because of what? Because of the data come from the data of dependent. Okay, meaning that you will have the data before and after. So that one is the dependent. Okay. So from here, okay, from the words in the example, okay, we know that the manager would like to know the improvement. Okay, so the word improve, okay, the symbol for improve is more than. So that's why it will become the one tail. Okay, so the symbol more than become the one tail. Okay, so note mu1 is before, mu2 is after, D is difference. All right. So as usual, step one is the hypothesis statement. Okay. So the general hypothesis is mu d equals zero for the null, and alternative mu d more than zero. Okay. Or optional, you can write mu1 less than mu2, or mu1 less minus mu2 less than zero, and mu2 minus mu1 more than zero. Okay. So the difference here, mu d is actually mu2 minus mu1. Okay. But when we talk about the hypothesis statement, it's normally started with mu1. So that's why I state that mu1 minus mu2 less than zero. Then it will become the left tail. Okay. So as always, step two significant levels is alpha equal 0.05. Okay. Then you go to the data analysis. Okay. You find the t-test paired to sample for means. Then you click OK. And variable one, okay, you need to input the mu1. Okay, you need to input the mu1, which is before. So just drag the before, sorry. Okay, just drag the before for variable one, and variable two is after. Okay, So hypothesis I mean different is 0. Okay, we always compare with 0. And since we pick the data from the label, then we need to tick the label. Okay, so just click OK. Okay, so just click OK, and you will find the data analysis, the output for the pair to sample forming is like this. Okay, so since this is the left tail, okay, left tail and also one tail. Okay, so the output highlighted is the t statistic, p-value for one tail, and also critical value for one tail. Okay, so what is actually the e minus 06? Okay, the e minus 06 actually the decimal places. Okay, meaning that the decimal places is 6. Okay, so it will become 0.000000182. Okay, so from here we can see that the output, the decision rule will be reject the null hypothesis because of the p-value less than 0.05, and also the test statistic is more than critical value. Okay, remember, when the test statistic is negative, okay, the critical value will become automatically negative because this is the one tail. Okay, so we go to step 4, decision rule. Okay, so since test statistic is minus 8.512, more than critical value minus 1.796, thus we reject the null hypothesis. Okay, so the analogy behind the minus 8 and minus 1, okay, you just need to know which one is more. Is it 8 or 1? Of course, it 8. That's why we said that more than. All right. Okay, and then p-value, since p-value is 1.802 e minus 0.6 less than 0.05 significant level, thus we reject the null hypothesis. Okay, so when we have our decision rule, okay, go back to our hypothesis. Okay, so we will take this one as our conclusion. Okay, or this one, okay, as our conclusion. So refer back to the paragraph. Okay, so it will concluded that it can be concluded that the new picking process improve, sorry, typo error. Okay, improve the picking rate of the pickers. Okay, because of what? Because we reject the null hypothesis. Okay, so I think that's all for the pack to sample for means. Until you can go back to me. Okay, if you have any question or anything that you would like to ask. Okay, thank you, student. And next, we will move to the ANOVA.